Good day, everyone. I'm Maureen P. Dades from BS Edma 3B, and we are now in 6.2 applications of the normal distribution. And I will answer number 3, that is population in U.S. jails. The average daily jail population in the United States is 706,242. If the distribution is normal and the standard deviation is 52,145, find the probability that on a randomly selected day, the jail population is A, greater than 750,000. So, the given are x is equal to 750,000. The mean is 706,242, and the standard deviation is equal to 52,145. Using the formula, z is equal to x minus the mean all over the standard deviation. Z is equal to 750,000 minus 706,242 all over 52,145 is equal to 0.84. The corresponding area to z-score of 0.84 is 0.7995. To find the probability that x is greater than 750,000, let's subtract 1 minus 0.7995. If you are questioning why we subtract 1 to 0.7995, it is because the area underneath the entire curve is 1. So that is equal to 0.2005. So the probability that x is greater than 750,000 is equal to 20.05% or 20.1%. Therefore, the probability that on a randomly selected day, the jail population is greater than 750,000 is 20.1%. We are now in B, between 600,000 and 700,000. First, we will find z-score for 600,000 less than x less than 700,000. Z is equal to 600,000 minus 706,242 all over 52,145. And that is equal to negative 2.04. And z is equal to 700,000 minus 706,242 all over 52,145 is equal to negative 0.12. The corresponding area to z-score of negative 2.04 is 0.0207. The corresponding area to z-score of negative 0.12 is 0.4522. Let's find the probability that 600,000 is less than x is less than 700,000. Subtract the two values. Probability of 600,000 is less than x is less than 700,000 is equal to 0.4522 minus 0.0207 is equal to 0.4316, or that is 43.16%. Therefore, the probability that on a randomly selected day, the jail population is between 600,000 and 700,000 is 43.16%. That's all.
What a good day! I'm Aljum Balyan from BS Ed Math 3B, and this is the exercise 6.2 number 11. And the question is, the average credit card debt for college seniors is $3,262. If the debt is normally distributed with a standard deviation of $1,100, find these probabilities. A. That the senior owes at least $1,000. B. That the senior owes more than $4,000. And C. That the senior owes between $3,000 and $4,000. So our mean here is $3,262 with a standard deviation of $1,100. And these numbers will represent our x. Our first problem is to find the probability that the senior owes at least $1,000. So the first thing we need to do here is to draw the figure and illustrate the area. Since we are looking for the probability of at least $1,000, it means $1,000 above. So our figure and area will look like this. The next thing we do is to find the z value of 1,000 using our formula z is equal to x minus mean divided by standard deviation. So we have z is equal to 1,000 minus 3,262 divided by 1,100. And that is equal to negative 2.06. The next step is to find the appropriate area in our table. So the area of negative 2.06 is 0.4803. We need to add the remaining 0.5. Therefore, the probability that the senior owes at least $1,000 is 98.03%. Let's proceed to the second problem, which is to find the probability that the senior owes more than $4,000. So, let's draw the figure and illustrate the area. Here, we are looking for $4,000 above. So, our figure will look like this. Next is to find the z value using the same formula. So we have z is equal to 4,000 minus 3,262 divided by 1,100, and that is 0.67. The next step is to find the appropriate area in our table. The area of 0.67 is 0.2486, and we will subtract that on 0.5. Therefore, the probability that the senior owes more than $4,000 is 25.14%. Let's move to our last problem, which is to find the probability that the senior owes between $3,000 and $4,000. So, this is the figure and illustration of area of our problem. Next is to find the z value using the same formula. For $3,000, we have z is equal to 3,000 minus 3,262 divided by 1,100, and that is negative 0.24. The area of negative 0.24 from our table is 0.0948. We already know that the z value of $4,000 from our second problem, which is 0.67, and the area is 0.2486. We will just subtract those two areas, which is 0.0948 minus negative 0.2486, and that is 0.3434. Therefore, the probability that the senior owes between $3,000 and $4,000 is 34.34%. And that's it. Thank you for watching.
Hello, I'm Daniela Bonus from Math3B. For this video, we will answer Chapter 6.2, number 19. New home size. A contractor decides to build home that will include the middle 80% of the market. If the average size of home built is 1,810 square feet, find the maximum and minimum size of home that contractor should build. Assume that the standard deviation is 92 square feet and the variable is normally distributed. So for our given problem, we have our mean, which is 1,810, and our standard deviation is 92, and here contractor decide to build home that will include the middle 80% of the market, and we need to find the maximum and minimum size of home that the contractor should build. So answer. The minimum size of home of the contractor should build is 1,732.72 square feet, and the maximum size of home that contractor should build is 1,887.28 square feet. Is it true? So for our solution, we have C is equal to X minus mean over standard deviation. So our Z here is negative 0.80 equal to P or the golden ratio multiplied by X minus 1810 over 92. So we just transpose our P. It should be 1 over P if we transpose it. But we can also write in this way, so we can just multiply it. So we have now negative P raised to negative 1 multiplied by 0.80 equal to X minus 1810 over 92. So why it became negative 0.84? P raised to negative 1 multiplied by 0.80 is obtained from standard normal table. In standard normal table, we have to see where 0.80 value falls. If falls, so it falls in row 0.8 under column 0.04. That's why we get negative 0.84. So we just transpose the 92, and our new equation is negative 0.84 multiplied by 92 equal to X minus 1810. So simplify it, we have now negative 77.28 equal to X minus 1810. So we just have to transpose 1810 in here to become positive, or we can just type it also like this. So now we have our minimum size of home that contractor should build, which is 1,732.72 square meters. So 2. The maximum size of home that contractor should build. So again, we have our formula. Then our Z is 0.80. As you can see, in minimum, we put negative in our Z, but now we are aiming for maximum, so it is a
Thank you
positive.
and
So we didn't put negative in 0.80. So just like what we did in minimum, we transpose, and then we arrive to 1887.28. So therefore, the minimum size of homes that contractors should build is 1,732.72 square meters, and the maximum size of home that contractors should build is 1,887.28 square feet. Hello, I'm Daniela Bonus from Math 3B, and for this video we will answer Chapter 6.2, number 27. Product Marketing. An advertising company plans to market a product to low-income families. A study states that for a particular area, the average income per family is $24,596, and the standard deviation is $6,256. If the company plans to target the bottom 18% of the family based on income, find the cut-off income. Assume that variable is normally distributed. So the average income per family is $24,596 and the standard deviation is $6,256 and we are asked to find the cut-off income. If the company plans to target the bottom of 18% of the families based on income, assume that variable is normally distributed. So for our solution, let's F denote the income. So we have given probability that X is less than cut-off income equal to 18% or 0.18. So the value of Z corresponds to the given probability values of 0.18 from the standard normal table. So let's check. Our percentile is 18 and our z-score should be negative 0.915. So, I'm sorry, there should be 5 in here. So we have formula z is equal to income cutoff minus mean over standard deviation. So let's just substitute for our z. It just round off, so it became 0.92. Then income cutoff minus 24,596 over 6,256. So let's just calculate and simplify it. So we get 18,840.48 dollars. Hence, the cut-off income if the company plans to target the bottom of 18% of the families based on income is $18,840.48.
Good day everyone, I'm John Cyrus Picabrasos from BS EdMath 3B. Here we have another problem from exercise 6.3, item number 35, which we need to find the standard deviation when the mean is equal to 110 and 2.87% of the area is to the right of 112. So I've already graphed the normal distribution and it should look like this. The 2.87% or 0.02287 lies to the right of 112. So it's all about this area. Then we need to find the area of the remaining normal distribution because we need it to solve for our standard deviation later on. We need to find this area. So 1 minus 0.0287 is equal to 0.9713. So this area is equal to 0.9713. Now we have the z formula. Z is equal to x minus mean over standard deviation. But we need to modify this. We need to modify this so that we could get the formula for standard deviation. So it should z multiplied by standard deviation is equal to x minus mean. Then standard deviation is equal to x minus mean over z. Since we have this area, this area, we could look its corresponding z value on table E. So 0.9713, its corresponding z value is equal to 1.9. Since we have all the variables we need for this equation, we can now get the standard deviation is equal to x, which is 112, minus the mean, which is 110, over the z. Our z is this one, 0.9713, and the z value is 1.9, so it's 1.9. Then it's equal to 2 over 1.9. So our standard deviation is equal to 1.0526. That's it. Thank you for listening.